Welcome to the December 16th Arborist call. Agenda today, brief welcome. We have research implementation updates for the node development teams, Zcashd, Zcashd. When we have other protocol teams in there, we'll be providing a standard slot for them as well. We're definitely looking forward to that. And then we kind of have an open period of discussions. Usually we have a few topics. I want to talk about NU5 today, of course. Just a reminder on the upcoming Arborist call schedule. We decided last time not to have one on the 30th, which is 2 weeks from today, just kind of due to the holiday season and everything. And then we have, kind of a wrap up for anything remaining. Definitely, if anyone has any questions or comments as we go, as we have the discussion and go through these items, please just let us know. It's much more interactive that way. Level set on what Arborist calls are. We get together bi-weekly to talk about the protocol. Anything coming, upgrades, R&D efforts, design implementations, new features, new potential feature, new proposed features, anything and everything protocol related. And the goal is to make it more accessible to a wider set of participants and provide transparency at these regular check-ins. Anyone can participate. Definitely register and attend. If you have a topic you'd like to present, just let me know. Or if you want to suggest a topic for us to discuss, you're not necessarily interested in presenting, you can definitely do that too. Stephen at electriccoin.co is probably the best place, or to the Zcash R&D Discord. Either one of those would work. Okay, and with that, I will pass it over to the foundation for a Zcashd update.
Hi everyone, it's my turn again to present the updates. So basically these 2 weeks, we've been working on a lot of network security fixes, improvements. I won't describe each one of them because most of them is very context specific, but just to give some examples, we fixed we are now spawning initial handshakes in separate tasks. This was an issue that was identified by Equilibrium, and we managed to do that to avoid hangs, for example.
Just a moment. Can you put your microphone down so that we can hear?
I'm using a table
microphone.
I don't use the one. Yeah, I know it's weird. Can you hear me? Okay, sorry. Okay. We did a optimization because when we were connecting to a peer, we had to do a bunch of time-related computations, and each of these read the clock. So, and this, this can cause performance issues. So now we just read the clock once and pass down to the functions that need them. In another example, we are now disconnecting from outdated peers on network upgrades, which is something that's specified by ZIP 211. So most of these are the network issues, and some of the consensus rules, which we were finishing, and we completed the last 2 weeks, were validating joint split proofs from Sprout transactions, and checking from the Sprout anchors. This seemed to work very well, but then we noticed that we were syncing the Zebra. We had some blocks that were fading. We spent some time investigating that, and Marek just found out that we kind of misunderstood the way the joint split interstitials anchors work. We didn't realize that you had to keep around the tree for each anchor to compute the interstitial trees. So yeah, I think we need to do some, not that big, but some changes in order to support that. But hopefully we will finish this, which will be the last probably consensus rule that we need for NU5. And yeah, so we're looking forward to that. And while we're doing that, we just went over our issue backlog to assign tasks for that we want to complete before the Zebra stable release, which is our next milestone. And the first one is completing the consensus rules, and the next one is doing a Zebra stable release. And so yeah, we're going back to the tickets we had created to check which of those we want to do before the stable release. And that's it. Thank you.
Yeah, interstitials are complicated. I'm glad we were able to get rid of them for sapling.
Mhm.
Yes.
Very good. Thank you. Appreciate that update. All right, let me get my screen back up again. Okay. Let's see, let me move a couple things. There we go. I need to close. All right, very good. I think I'm good now. Okay, so moving on. Zcash D updates, we typically at the moment are focused on NU5, so we don't have a specific update for Zcash D other than the update for NU5. So we'll just kind of roll right into that. This is, again, for sake of completeness, these are the NU5 zips that we have going into the upgrade. These zips are the ones that are modified, meaning there's some accommodation in there for the orchard pool, for example, like zip 209, preventing a negative balance in the pool. So we just kind of modified the zip to indicate it applied to orchard as well. Yeah, so that's kind of the list. What you may have seen earlier today is we announced a shift in timing for NU5. Essentially, short version is we shifted the activation target to April, which is kind of reflected here in this graph. This is a little different than the timeline I normally put up. I have that on the next slide, but I just kind of wanted to highlight a few things here. We are roughly about a few days ahead of 460. So that we're looking to get a release candidate out tomorrow and cut 460 next week. We were originally anticipating a network activation roughly on the 17th of January. So we had all the 4.5 releases EOS halting on the 10th. For those that aren't familiar with that, we manage the service span of a release, which defaults to 16 weeks, but we manage that around network activation so that we don't have an active release in the field that doesn't support the consensus rules that we'll be activating with the network upgrade. So we're getting 460 out. So we'll have a release in the field when the 4.5 releases EOS halt. We'll follow that with 470. We're targeting later in January for that. At that point, we will have 470 and 460 will include in combination everything for NU5 except the mainnet activation height. We wanted to get that in and get it running on testnet and have some period of time to work with partners and obviously our own testing as well, and anybody else that wants to test prior to the 500 release, which would be the one that set the mainnet activation height. And that's, I forget the exact date, but sometime roughly late February, in February is when that would set. Important to note, with 470, we will be rolling back testnet. So there will be a testnet reactivation that will occur roughly 2 weeks after 470. Usually it occurs sooner than that just because the block time, or sorry, block time is a little less predictable on testnet due to, kind of inconsistent mining. And then, of course, we have a 510 that activates or comes online prior to the activation. Again, the goal is to have 2 releases in the field that support the network upgrade. 460, 470 will EOS halt prior to that. And that's kind of the schedule for this kind of Zcashd. It's got the NU5 events on it, but the above the line are essentially the Zcashd release numbers that we'll be putting out. So again, next up for us is putting out 460 next week. 470 in January would be the next 2 items up on the list. The way that looks, this is the kind of the graphic I typically use. It's very similar. Partner adoption obviously is extended out to NU5 activation. We're making progress with some partners. Obviously, we need full NU5 support on testnet to be able to do that. That was one of the reasons for electing to push the activation, was having that support in place and then having inadequate time with our partners to do testing. But we've got a number of exchange partners that are making progress. We're working with some miners and of course wallet vendors as well. So we're making progress. We can kind of honestly do ecosystem outreach in earnest once we have the 4.7.0 release on testnet. So we can make sure that everybody's kind of checking off the things they need to look out for depending on the type partner that they are. So I'll pause there, see if there's any questions in chat, or if anyone on the call has any questions, or would like to, if anyone else on the team has any kind of comments they would like to add to what I just went over. See, Deirdre has a hand up. So Deirdre,
Sure.
go ahead. Mhm.
Any specific motivators for pushing back activation? I know there's been some changes to improve the circuit, but not significantly change it. I think some of the security proofs are done for that. The thing that seems to, based on the blog post and what we've been working on the zip editors meetings, the things that seem to be more in flux are like unified addresses and things like that. We've been tweaking those. That hasn't slowed down. So any indications of which specifically prompted needing more time or wanting more time of any of that sort of stuff?
Yeah, let me try to back up a slide. There you go, Strad. Go ahead.
Yeah, it's primarily unified addresses, I think. The amount of effort it's taken to actually get a consistent improvement, integration to the air has been. We have repeatedly underestimated the amount of work it's required to cajole this into the Zcashd code base. And so, yeah, to the point that we were hoping to even, hoping to get it into 4.6.0, and that has not happened. So that's not going to miss by too far, but it has to miss because we have the holidays coming up and we can't safely delay that any further.
Right. We also had a few minor changes to the semantics of viewing keys to make them work more consistently and have the correct separations between keys.
Right.
Yeah, I don't think those changes affected it too much, but they will have had an effect on the delay.
Schedule.
I don't think they had so much of it. I think that was more we've discovered pieces about how the integration, as part of the integration, like we've discovered more about how UAs really interact, which itself is like, it lends itself very strongly towards something I've wanted for a long time, which is like having more of the stuff implemented further in advance for subsequent network upgrades. So yeah, that's definitely something to go into the retro for in U5. But as far as like the remaining stuff for that, I can pull up the DAG if you want to have a look at that. But
that would be useful.
Yeah, I can stop sharing. Go ahead, Deirdre.
Can I raise a question that I just want to put it out there?
Sure.
Not with no thinking what it should be or what the answer shouldn't be. What if we didn't do unified addresses as part of NU5 and the Orchard release? Not we should or shouldn't, but what if?
Just what if, right? So
what if we didn't, as in if we extracted unified addresses out, well, we would be committing to having a standalone Orchard type, and so that would require extra implementation work on that side, because to define and implement that. And then it would just be the extra complexity of, okay, now we have to maintain, that would cause issues, I think, in downstream wallet side, because rather than them being able to, from a UX perspective, just migrate from here is our sapling wallet to here is a unified wallet that under the hood just absorbs the sapling stuff and it just works. All of those designs would now need to switch to, okay, now you need to be aware of the fact that you have multiple different addresses and multiple different pools, and the wallet wouldn't be able to handle that for you.
So just to add on there, definitely I mean, definitely unified addresses provides a UX, plus or benefit if, for Orchard. The one thing we've discussed kind of in retrospect is when unified addresses were kind of conceived, we joined them at the hip with Orchard. Like, oh, that's how we improve the UX for Orchard. In retrospect, we could have at that point went, wow, unified address is a really cool UX concept. We can actually implement it right now with sapling transparent addresses. So we could have, and I'm not suggesting, it's kind of like your question, Deirdre, I'm not suggesting that was the right thing to do, but it's an option we didn't even really think of, was like, okay, wow, maybe we ought to press pause, put out an NU with unified addresses in it, maybe transaction malleability fixes or, whatever else would fit. And then once that's in, and that, because that has been a lot of support in the wallet, then we could have looked at, okay, we've got that in place, everything. Now, what's the runway for NU6? And that's when Halo comes in. Again, not saying that would have been a better call, but it is something we thought of recently.
Yeah, definitely as we've continued to prune the DAG and discover how to actually get this integrated into things, it's become a lot clearer. And
even if unified addresses and Halo had still been in the same upgrade, we could have implemented unified addresses earlier in the timeline, I guess. The difficulty was that the audits were still in progress. So.
Yeah, I'm not convinced we could have done them earlier. Like I think what we're running into here is just a limitation of like how much engineering time it's taken to get it all done, and that unified addresses has been more engineering time than had been expected. I mean, Orchard has also been more engineering time than we all expected because it's a behemoth. But I think that was at least maybe known complexity and sort of expected complexity. And UAs were not expected complexity.
Right. Deirdre?
Yeah. Can you talk a bit about where you found the complexity in trying to integrate them into at least the Zcashd code base? Is it just basically like all of kind of Bitcoin influenced assumptions in such a code base expects a key, a address, not this sort of, just where you found that complexity, sort of like the unknown unknowns that you had to unravel?
Yeah, I mean, if Chris is on the call, we can, I don't know if Chris is here. Could speak more to that, but in short, yeah. I think it would have been an easier time, and in fact will be an easier time, for example, for the mobile wallets that that are just starting from effectively just a single wallet, single key sapling approach, or for example, when you're doing your Zebra wallet, starting from scratch and can sort of build it around that UX. Whereas there's a bunch of sort of existing machinery that we need to sort of deal with.
Okay.
Yeah, and we basically have to implement it twice, because we have to implement it in Rust, and then there's all of the interfaces to Rust on the Zcashd side.
And there's a lot of complexity and brittleness there. Like one of my other long-going things is keeping an eye on the CXX crate, which you might be aware of, is like I think David Tolnay and that are working on to try and make it easier to cross C++ and Rust boundaries that I think Google is also interested in. The last couple of times I've tried to use it, it's not quite worked for our use cases. But the result of that is that like a lot of this is just manual FFI coding and things, and manually shoving bits across and making sure that everything's consistent and all that. And it expands a lot. I think also
FFI code is very error prone and requires a lot of review.
Yeah. There's also actually thinking on that note, there was an aspect of, for sapling, we did a lot of stuff on the C++ side, duplicate. But as a result, we sort of like could do it relatively easily to get like parsing and stuff. but it did lead to some inconsistencies in terms of like exactly how like points were treated as byte arrays and things. And as you know, that has led to some inconsistencies that we had to deal with, like with zip 216 and other ones, in terms of how the consensus rules were handling things. And our desire this time was to put more of that, like as much of that into the Rust side as possible, which meant a lot of FFI wrangling that we not actually had to do before.
Got it. Thank you.
Yeah. So with unified addresses being such a, call it partner facing thing, we needed that support kind of locked down before. I mean, folks can test like, version 5 transaction format compatibility, and okay, the upgrade's not breaking anything related to sapling. So business as usual from that perspective. But to really test in earnest with the partners, I mean, we'd love to have a number of partners on board when we activate with, shielded by default, if you want to call it that, as well as support for unified addresses. We just needed that support on testnet for a longer period of time than we would have otherwise had it. The other thing which is going really well is the security proof. Mary Mahler's begun her last pass over that this week. That's looking really good. But that's always been a gating factor for us for setting the mainnet activation height, the 5.500 release.
Yeah. So with that being like not being completed until the end of this year, we wouldn't have been able to define a mainnet height prior to next year anyway. And so I guess that's the other aspect of, we need to ensure that there is enough time between setting that and having people actually activate it. I think we've spoken in the past about how, like, I think it was like a month and a half is like the bare minimum. And I think with this new one, we have about 2 months.
Right. Yeah, 2 months roughly. Yeah, within a few days. Tayor, that question?
I was just wondering when we can expect to see Orchard transactions on the testnet, because that's important for us to know if we start to see failures in Zebra syncing.
Yeah.
So bear in mind that this testnet reactivation is actually a rollback to the activation point, the original activation point. So all of the transactions between those points will be rolled back.
Right, but we haven't had anything on chain that has used Orchard yet because we haven't had anyone building it.
Right.
So as far as transactions being built by Zcashd, I expect like we will probably start to see those in mid-January, I would say.
Yeah.
Because that will be when we actually have all the transaction builder stuff in for 4.7.0, and then and we'll be able to test that on current testnet with the current circuit before rolling out actual 4.7.0, which will contain the proposed final mainnet circuit with its changes that then will necessitate the testnet rollback.
Thanks. That's helpful. It helps us to know we aren't building any transactions yet, so we would be relying on other people to build them.
Okay.
Yeah.
All right. Very good. Any other questions or comments or anything before we move on?
Were we going to look at the DAG as well?
Yeah, I can bring that up if
Okay.
you want.
Yeah, I'll stop sharing the screen, and yeah, you can. Okay.
Make sure I'm sharing the right one. There we go. Does that come up?
That's
Yes.
color.
Yes, I've
Yeah.
Oh yeah, this is the dark mode that I came up with.
Maybe zoom in a little bit. I can't read that.
How's that?
Okay, that's better.
Yeah. So
So
we
you
have,
can see there's a lot of parallelism here.
Yeah, but there's also a fair bit of blocking. So like adding unified address key generation and storage to the wallet has been quite a bit of a large chunk of work that is finally in a PR that we're reviewing right now. And once that's out of the way, then it's just connecting it into everything. But like there's been some fewer nodes in back here that were reasonably heavy in terms of what they required. So yeah, so we've segmented off all the rest of the pieces that we were going to put into 4.6 anyway, like bumping to ED 25549 Zebra 3, some fixes to the mining logic, just some other bug fixes and things. And also we're going to bring in the current Orchard crate version. We're going to publish that as a 0.010 beta 1, so that I think at that point we will have the entirety of Zcashd on non-patch versions.
Great.
Everything should be on a published if beta release, which should hopefully make Zebra's integration side a bit easier as well. And then you can see down here, there's the remainder of the stuff towards getting the mainnet circuit piece done. We've made all of the circuit changes, and in fact done some refactoring that we thought would be circuit changes, but we managed to do without. And so now the last big piece is just doing this prefactor to extract out this Halo 2 gadgets repo that other people can use, and then that's basically it, I think, before we can cut the proposed mainnet version.
Yeah,
and
there have been some nice API simplifications to how you write Halo 2 circuits.
Yeah. And we also took, I think I mentioned previously, we took some time to like normalize various parts of the circuit so that if someone's trying to use it in a different context or, write it with a different prover, it's easier if like all of your Boolean checks are constructed the same way rather than being somewhat ad hoc.
What do you mean by in a different context?
So imagine like someone wants to write a JavaScript prover or a Golang prover or C++, like if someone wanted to write another version of the Halo 2 proving system, for the Halo 2 like the Halo 2 crate in Rust, if they wanted to take the circuit from that and have it be compatible with some other backend, just having so it's in the same way that like for the R1CS circuits in Bellman, like the gadgets used there, we said you had to sort of agree on like, this is how a numeric gadget is built, or this is how a Boolean gadget is built. This is, all of your Boolean constraints are x times 1 minus x equals 0, rather than like x squared minus x equals 0, stuff like that. So just like setting some patterns that make sense, so that then if someone else builds something to try and be compatible with it, then they have a better chance. And also just makes it easier for people reviewing the circuit to sort of know what they're looking at and what they're dealing with.
And also potentially to make some of those gadgets usable in other circuits. Although a lot of them are specialized to the pasta calves at the moment, but it reduces the effort needed to port them to something else.
Yeah. Have you guys been working with anybody else on that stuff?
Yeah, so I think Yingtong's not here because it's too late, but Yingtong's been, I think, hacking on the side with some ZK EVM people, just playing around with Halo 2 for like Ethereum stuff. And they've really been pushing it to the limits. Like, Orchard is using K equals 11, so a circuit of like 2048 rows. And they've been dealing with, I think they're up to like K equals 25 or something ridiculous. We're getting some interesting issues on the tracker of like, can we please maybe make this part of it more efficient because it's using 50 gigabytes of RAM?
Whoa. I was going to say, how efficient is it when you've got 25?
Maybe if you're in those contexts, then maybe don't like just pre-compute these particular lookup values and instead maybe do them on the fly. So yeah, we're getting some good user feedback from some interesting contexts that is going to feed into improving the implementation as a whole.
Yeah, and there's still some performance improvements on the table. That we know are possible for Orchard size circuits.
Yeah, it would be nice
for any size circuit, really.
Yeah, I think the biggest one is the parallelization improvement, which will also help those big ones. Which is the fact that currently we're losing a lot of time to context switching because we're parallelizing quite low down, and the process for inverting everything and being aware of like the expression AST created by your gates to be able to apply it to subsets of your polynomials. That process also lets us do other optimizations, which themselves then help the people who have ridiculously large lookup tables. So, yeah, so like the actual orchard pieces of this are sort of, tracked up here, but most of this is just, get the UAs in, get the, well, it's no longer going to be coherent subset because that was when we were trying to get into 4.6. So this would usually get the UAs into the logic. And then once those are in, then we can just sort of plug orchard into the side of them for 470. Also, I rendered another version of this, which includes everything we've closed out.
Yeah, so that's NU5.
Yeah, there was the orchard consensus specification just in there. There's been a lot of work going into this. So, and this does not even capture this, like there's a lot of stuff that happened that we just didn't pay attention to and track in the DAG, but yeah. So I really like my visualizations, if you can't tell.
For a split second, when we looked at this morning, or earlier in the day for me, so morning time for me, I literally, I think my heart stopped momentarily because I, at first glance, took it as this is all of NU5 remaining, but it's actually, the bulk is behind us. So
yeah. Any other questions around the pieces remaining or integration lines for that?
Oh, just one thing to add, I forgot to mention it earlier, Deirdre, when you were kind of asking about, the things that kind of some of the reasons for needing to push the date. One of those is we want to do another internal review of the circuit. So we had NCC, we had Kedit, both did a great job. We did a review internally already, caught a couple of circuit bugs that affected testnet. So that was the 451 release we put out. And once everything is kind of, final, we want to make a thorough pass through the circuit again, just kind of for everyone. And that includes Taylor and security as well, to kind of give it, that one more thumbs up prior to setting a mainnet height. So,
yeah. And like we'd been doing that, but like the amount of, like the time that it's taken to do the UA sides of things is sort of taken away from the time for that. So just more time.
All right. Any other questions about the DAG or anything remaining for NU5 or?
Yeah.
Okay. We're good, I think, on that one then. So one of the things that Dodger and I were discussing earlier this week was kicking off an NU5 retro. Obviously, we'll take more than one call to get through, but we can we could with the time we can discuss anything anyone would like with the time remaining. That was one thing that we had tossed out as a potential for today. So just kind of leave it up to Dodger and the foundation team or other folks. If they would like to kind of start that today, we can definitely start taking some notes and then continue it, at future Arborist calls as well. So
yeah, we've sort of started it already.
Yeah.
I'd argue, but
right. Deirdre?
So on the like round whatever of internal review, that kind of makes me try to want to figure out how we can reproducibly get that sort of result out of whatever process we have when we're making circuit changes or adding a new circuit or stuff like that. Because we had very good external audits, but it was only when the people with the most knowledge cached in their brains taking a fresh look at a thing with external context from those, with external POV from those audits, were able to find a bug that needed to be fixed and so on and so on. So it'd be great if we could find a way to synthesize that into, I don't know, NU5, the network upgrade process to make sure that we try to achieve that reproducibly. Thoughts?
Yeah, I concur there. The providing space away from the circuit is often useful there. Like and I think the density of stuff that's needed to be done for this compared to previous ones is sort of like meant to, like if I think back to like what we did for sapling, for instance, a lot of the gadgets and things, we were optimizing stuff that was already like reasonably there and reasonably well understood. And it was just like, you know, let's apply our compilers to it, i.e. Dara. But we've sort of been having to sort of do that in line here. And I think if we've been having to implement the compiler in my head and in Yingtong's head. Yeah. And having more of that in the code and more of the support structure in place, so we can not have to worry about some of the more basic stuff and can think more about the overall protocols and things, that would definitely help.
Yeah,
I mean, I would still like to have a DSL to write circuits.
Yeah,
I was gonna say, like, should we seriously invest R&D, like we Zcash protocol developers, into a real compiler for circuits, as opposed to forcing our humans to just, reinstantiating, a compute runtime in their brains for every new circuit or, whatever we come up with. And like,
yeah, I mean, don't get me wrong, there's going to be a lot of human creativity, even if we have a DSL, but
yeah,
it'll get rid of some of the error-prone grunt work.
Yeah.
Yeah, I think
I'm very enthusiastic about it.
Yeah, I know when we've talked about this in the past, we've talked about, like, when we look at other DSLs, a lot of DSLs are focused on just like simplicity of implementing stuff. And a lot of times that just comes down to hiding away the complexity and having like one person write it by hand. And that doesn't help that particular person. Versus the sort of stuff that we would prefer is the ability to like be aided in the optimizations we're doing, but still have the ability to make them.
Okay.
What I want is for the language to have full abstraction. In other words, anything that you could implement implement manually is also possible to express using the language. And that's difficult, but it's doable.
I do know that someone in the community is interested in working on a DSL for Halo 2 as well. That I think they reached out to Yingtong, or Yingtong was aware of the project or the desire to do that.
Yeah,
it'd be good to no details beyond that.
Yeah, it'd be nice to have like maybe a working group of a couple of people who are particularly language oriented, to try and make forward some progress on this, because it would definitely make the next circuit change easier to, in particular, review.
Right.
I would really like to have an in-person meetup to sort of thrash out the details of this language.
What? Are y'all having a?
That might be a bit delayed.
Well, yeah. Right. I mean, that would be like an excellent. Y'all are doing a ZCon, I know, right, Dodger, this year? I don't know if you're going to try to have it in person, perhaps, but that might be like an excellent opportunity, like a working group or something, or to continue like something we'd already started.
Yeah.
There.
Well, I think I don't know if anybody was planning to go to real world crypto, but I'm not even sure if they've announced. I haven't checked in the past 48 hours or so. They've canceled the in-person. component?
Yeah, it's been postponed to mid-April.
Yeah.
Right.
Oh, right.
Okay.
Yeah, I guess with the uncertainty about Omicron.
Yeah. So I think that really just illustrates the changing landscape and the fact that we could plan, we could book, we could have everything lined up, and then a week or two before a new variant could emerge and could completely kibosh the entire thing.
Mhm.
So yeah, Zcon, we hope it'll have an in-person component, but it will definitely have a virtual component. So
Right.
Yeah, that's sensible.
This year's, last June's Zcon 2 Lite seemed to go down very well. There seemed to be a lot of positive feedback, perhaps partly because people were starved for anything approaching a conference experience, and we managed to deliver at least something approximating that. But yeah, I think the fact that was well received, I think has given us confidence to say, yeah, let's do a Zcon. Hopefully there'll be an in-person component, but there'll definitely be a virtual component. If we can't do in person, it'll be all virtual. So yeah, no,
Yep.
I do totally understand where Dara's coming from. That in-person meetups where you can sit around in the hotel bar drinking tequila. I'll dig out those photographs actually, and drawing out things on bits of paper.
I mean, that's literally what Dara and I did not long ago to figure out the payment disclosures for Orchard.
Yeah.
So we have that circuit all written out, which that again would be lovely to have a DSL for.
Yeah. So yeah, I do totally totally sympathize with the desire to have an in-person thing. So I think there is more scope for creativity and productivity in an in-person meetup.
I'm hoping there'll be a tailored vaccine to Omicron soon, because the work has already begun on that. So very soon after Omicron was identified.
Yeah.
Deirdre.
Oh yeah.
So for network upgrade stuff, retro stuff, one thing that may continue to be true, even if we don't bite off large chunks like a Orchard, like unified addresses or something like that, is that it did touch, this network upgrade did touch many zips and add many zips. And I think not even if we start deprecating stuff like Sprout, but just by a function of the protocol having features, and we keep supporting things and adding things, and it has been alive, as it were, and growing for 5-6 years, that a 6 month time scale for a network upgrade may be untenable. And not because we're biting off big chunks like Orchard and unified addresses, but even if we just had Orchard and no unified addresses, it would still be a lot. And I think part of that is that there is a lot of Zcash, and there's a lot to support, and it touches a lot of pieces, and we have to update all these things to support the new thing, and so on and so on. So I wonder if we might have to reevaluate scheduling, but also kind of keep that large scope in mind whenever we're making fundamental changes, I guess, instead of little nibblies around the edges.
Yeah.
That it will I posit that it will be strictly larger every time, just because we're not doing Orchard to, I don't know, Zcash that's been around for a year. We're doing Orchard to Zcash as it exists after 5-6 years, including Light Wallet, including this, that, and the other thing, including many zips that have been added to support or address this, that, and the other thing. And so we might need to reevaluate how we plan and estimate to take that into account.
I agree. Remember that we do need network upgrades to remove consensus features as well as to add them.
Yep. Right. Tayor?
That was actually exactly what I was going to say, is that
Okay.
one of our options is that we can schedule and invest significant engineering effort in making the protocol less complex. So I understand that some things we want to get rid of are blocked on making decisions about how to treat old transactions and old unspent ZEC, but there are still things that we can do to simplify either the network protocol or to checkpoint somewhere and to explicitly get rid of old consensus rules and those kind of things. So these things will literally allow us to delete code, and I think that we should seriously consider in every network upgrade some kind of deprecation or reduction. We can just simply say that unless we come up with that, we won't schedule a network upgrade, or someone is going to have to do that work for each network upgrade. Otherwise, Zcash will just become unmaintainable, and we don't want to go there.
Yep, I agree. The maintenance aspect of things is also one of those ones where, like, so for example, the proof of stake stuff that ECC is going to be looking at over the next patch of time, like, that's also potentially going to be a large change, but one that potentially also results in like replacing a bunch of existing code. And at least there, for example, it would be a replacement, one that maybe needs to sort of operate alongside for some period of time, but otherwise you can't verify any of the proof of work stuff with on a proof of stake network. Logically, just it doesn't make sense. I think there is a decent argument for, even though we are technically full nodes, we already have, as Zebra is sort of going a bit more full into it, of like checkpointing specifically on an existing height. Zcash still tries to enable you to verify most of the existing rules, but we are going to get to a point where we just shouldn't, because the upside of being able to go and verify the entirety of history is outweighed by the downside of the risks of having all of that extra code on the current maintenance burden. And you can emulate it by get an old version of that, run it until it hits the OS halt, upgrade to the next version. Like, it's kind of like the bootstrapping problem for compilers, where like you might have to, if you want to get back to its original history, you have to run it, compile a couple of daisy steps to get there. And if we just provide like we can say what versions you have to run to enable that if you wish to be able to verify the entire chain history.
I mean, we already relinquished the ability to verify all consensus rules from Genesis, because we no longer verify BC3 14 proofs.
Exactly.
And,
But that was
but you could download an older version.
Yes, you can download. You could run pre-sapling Zcash up to sapling activation to verify all of those. And you could still do that even if we disabled whatever other bits we removed. I
mean, it's actually quite tricky, because if you try to run a pre-sapling node, or even a node just after sapling, then it will have a peer protocol version that will get rejected by current nodes. So it won't be able to be
that is
a
true.
full member of the peer-to-peer network. What you can do is just download the blockchain and get it to verify that. But I think having the tool that does that be a full node doesn't really make sense. We might want to have a standalone tool that is able to verify the blockchain before a certain point. But obviously that's extra work to implement.
Yeah, that's a good point.
Just using a full node won't work though.
Taylor?
We, as part of our work for looking at the different, looking at the database changes we need to make for our client work, I went and implemented a verifier that can just take blocks off the disk. Well, in this case, it's blocks out of an existing database. So yeah, I know that that's a lot harder in Zcashd, but definitely if we want to do that for older versions of Zebra, that will be possible once we're at NU5. And it will be quite easy for Zebra, but yeah, we don't plan on implementing rules that are inactive as of Canopy.
Yeah. I mean, from a security point of view, it's not clear what validating the old chain is even getting you, because if you don't trust the network to have validated that correctly up to sapling, then you probably shouldn't be using Zcash.
I thought I got curious and I found this.
Ah, there you go. All right.
Is that my handwriting? Yeah, that's definitely my handwriting.
Whose hands are those?
Oh, that's my hand. Right. Yeah, I recognize my face.
Yep, and I'm guessing, yeah, that's the sapling note plain text there. This was, I think, yeah, discussing all the
oh, that's
value
the circuit size. Yeah. So 1881 is the is that the cost of Pedersen hash as it was?
Oh, there we go.
Yeah,
Yep.
it
And
actually
there's a
says
break to it.
Pedersen. Okay.
Yep.
It's actually that was an earlier stage of implementation. 29 Pedersen hashes, 2 Blake 2s hashes. Yeah, so
that's right. When it was, because we were going to use 29 because that was the same depth as Sprout.
Yes, exactly.
And then we decided just to bump it to 32 because nice round number.
Yeah, so this is basically proving that the size of the sapling circuit was going to be less than 2 to the let's see, what's that? So that's 2 to the 17.
There was a performance step, wasn't there, at a certain point where?
Yeah, we still have those performance steps. That's just how the current powers of 2 FFTs end up working.
Anyway,
quite a
little bit of history
shots
there.
Yeah, quite a few tequila shots on that table too.
That's why I mentioned the key. I wanted to explain why I mentioned the tequila fueled crypto design in-person meetups.
Right.
One thing makes a good rocket fuel.
One thing I will observe is that this conversation about reducing complexity is one that we have had before.
Right.
And I think we need to start being serious about deciding what we're going to do, because it's clear from this experience that we've had that simply blindly increasing the complexity comes with major costs, major risks, and I think it behooves us. We have a responsibility to our users and to the Zcash community to act responsibly and to not simply push things forward.
And to our future selves, or whoever takes over protocol development from us. Yeah,
to not lumber the next generation with our sins. I'm pretty sure there's a climate analogy there as well.
Oh yeah, exactly.
But yeah, we need to get serious, and I think we need to start revisiting some of these discussions that we've had in the past about deprecating the Sprout pool and how we could do that. I understand that Strad had some ideas about being able to allow Sprout node owners to claim their notes.
We discussed this, I think, in a couple of earlier Arborist calls. So,
and also the question of how much of the protocol is going to transfer to the proof of stake chain, under the assumption that that's a separate chain which I think it probably will be, that there'll be some cross linkage between chains. The value of the token obviously will be preserved.
Yeah, that might be an excellent opportunity to essentially deprecate away functionality on the Nakamoto chain, and then you kind of carry over the latest and greatest to the proof of stake chain, for example.
I mean, I
assuming
would like
the community wants us to move to proof of stake.
Yeah.
I would not.
like
I would very much not take that as a fait accompli, which seems to be a little tactic that seems to be emerging.
Yeah, I mean, the feedback again, it's not like a scientific thing, but it does appear that people are generally supportive of that, based on responses to blog posts or, in the forum or Telegram or wherever,
supportive enough that it's worth putting the time into figuring it out.
So if we do end up going to proof of stake, I would very much like that proof of stake to only support Orchard. So shielded only, Orchard only.
Yeah. And that's also similarly for like the scalability stuff we've talked about in the past. Similarly, like it needs to be a protocol that can be scaled, and some of the legacy stuff just can't.
Let's see.
It's probably worth noting that scaling includes the network protocol. That some of the parts of the network protocol simply can't scale, and they're also quite difficult to secure. Let's be honest.
Yep.
There's a lot of very messy state management in there.
Looks like Deirdre. Yeah, Deirdre has a hand up.
Thanks. Wanted to mention that in terms of managing complexity, I note a couple of slightly differing ways that we can that it affects us as trying to make changes. There's strict deprecation for stuff like Sprout, like we'll just rip that out of the protocol. We get to delete a lot of stuff. And then there's stuff like changing uses of addresses to this new paradigm of unified addresses. And that's a slightly different thing to tackle, because it's basically changing a fundamental assumption that kind of goes back all the way to the roots of Bitcoin in a way. And I think me asking questions about Stradiva, like what weirdness did you discover? What problems and complexities did you discover when you were trying to do that in your existing code base? Basically was an excavation of like unknown unknowns in terms of like how deep the roots go. So there's several of those factors that I think we need to keep in mind when we're trying to either deprecate, reduce complexity, or manage complexity to allow us to make changes into the future. And that's kind of it.
Yeah, one of the things that I learned on today's call is that it sounds like in the future I will no longer be able to give someone my Orchard address, or I won't be able to give someone my Orchard address because it won't exist. Or it won't be part of the
There are no standalone Orchard addresses, but
yeah,
you can have a unified address that only contains an Orchard address.
So that feels like what we're now doing is we're adding complexity at quite a low level, at quite a base level, when it could have been done at a slightly higher, more abstracted level at the UX. And it's a bit of a surprise to me that it won't be possible to have a standalone Orchard address. That wasn't my understanding of from previous discussions.
You can have an address that only represents Orchard pool.
But it must be a unified address.
It is a unified that unified addresses are that high level abstracted UX layer. That is what they're geared at. And in order to promote them and not increase the cognitive load on users, we didn't define a encoding for just like we had a sapling address. We didn't define an Orchard address encoding. It's just if you have a unified address that has an Orchard component, and you can make a unified address that only has an Orchard component, which is equivalent to having an Orchard address. But it still focuses things down the you don't have funds in an Orchard pool. You have funds on the network that will exist across a set of those pools, and your wallet manages that complexity for you.
So the layering hasn't really changed. Addresses have never been part of the consensus layer. You have the cryptographic components that are part of consensus, but how you represent those as strings, that's never been consensus. And so that's what we're changing, really. It's still the case that the consensus protocol still operates in terms of individual addresses like transparent, sprout, sapling, orchard.
Yeah,
but because they're all shielded, you never see them. So you don't have to worry about them at the consensus layer in the same way you have to worry about the transparent layer. I'm just wondering how this may impact third parties' abilities, or the challenge that they may face when building tools to integrate Zcash with other systems.
So if you generate a UA using zip32, so from a mnemonic seed, then which is the only thing that Zcashd will do. If you have one of those addresses, you can, is this true? You can infer the unified address that
yes,
it would be contained in. Do you have to know the key path as well, or is it the case that you can infer it just using the address
that it corresponds to?
You do need to know you can't just give the on-chain, you have to know the on-chain address corresponds to some HD derived secret. Like you have to know, you have to have that a priori, but once you have that, you can derive everything else.
Right, because we don't want it to be possible to link addresses
on chain.
On chain, unless you have at least the FVK.
Yes. So if there were any way on chain to detect that we were using UFVK, unified addresses, then that would imply there was a way to distinguish someone who's has a UA that's combined sapling and orchard versus orchard only versus orchard transparent river, which is a distinguisher that we wouldn't want. And also just adds to the complexity because it starts interlinking the individual protocols in a way that becomes even more complex than just having the individual protocols on their own.
Yeah, but if you have an FVK, then you can recognize all of the uses of those addresses, regardless of protocol, on chain and link them together.
Yes, I mean there are some minor caveats to that, like for the transparent components, you have to actually do the same thing that Bitcoin wallets do with having a gap limit, because they're, unlike with sapling and orchard addresses, you don't have diversification built in. You actually have separate keys for each of the children. So you have to do the same thing that, like I said, the Bitcoin wallets do, where you look and see, okay, do I have funds received at this address? Do I have funds received at the next address? And they scan up to 20 or whatever their gap limit is and if they don't find anything, they decide they're done. But that, like I said, that's something that Bitcoin wallets have to do. So I don't think it's a big extension for transparent supporting Zcash wallets to have to do that.
And
for as long as we support transparency, at least.
Yeah.
And we haven't mentioned how Sprout fits into this. Basically, it doesn't, because you can't send to Sprout.
Yes. By design.
Yep.
No
by
Sprout
universal acclaim and support.
Yeah. I mean, also just cycling back to Taya and others' points about like removing and deleting bits of the code, it is also worth just thinking like what bits can actually be deleted or are worth deleting. So like in the case, so I get the thing about not bothering to implement rules that are already deactive. But in the case of something like Zcashd, it's almost more effort than it's worth to go in and remove them. Where like, there is some, I guess, argument to like when we're implementing new rules, I guess you could argue if the new rule is interacting with code that was also interacting with rules that are no longer active, then you could take that opportunity to prune them. But otherwise, it's like, it's verifying, it's not failing or anything, and like actually altering the structure to like remove that, but it doesn't save you a lot versus say deleting a signature scheme implementation, which does save you a fair bit of that complexity.
When we, for example, removed libsnark entirely, that was a huge simplification.
Yeah, I mean, something that I found in the implementation of unified addresses is that implementing things in this fashion where we want to start treating the sub protocols of Zcash in a more modular fashion. This is something we're doing anyway. All of the orchard logic, for example, is implemented in Rust, and we can have relatively, in the C++ code, we can have relatively small wrappers around that logic, but having the protocol be modular will also enable us to remove pieces in a much more wholesale fashion in the future.
Yep. Versus currently where a lot of it is just, in Zcashd in particular, all of the code pathways are just sort of single threaded, single track, big pipeline that you just have to
try all these different things one after another rather than having, effective branching.
Yeah, and there is a risk to refactoring that. In the same way that there's a risk to re-implementing it in a different node. What is it that, like, what's that Google metric? I think it was I saw recently that like 50% of their bugs occur in code that's less than a year old. I think that was the memory safety bug. That was the one where they're like, they were focusing their Rust work on all their new code rather than existing code because nearly all of their bugs occurred in the new code, and it was better effort to focus that way than to rewrite all of their old stack.
Yeah.
I've realized I probably should have been holding up my hand rather than just speaking. But one thing, I just want to touch on something that you said there, Strad. You talked about how it's almost more effort to remove stuff that's already there. And that may be true for ECC and for Zcashd, but it's a different story when you're implementing an alternative node implementation from scratch. And so there, you've got a kind of a seesaw effect. Less effort for you guys means more effort for us, Yep. And it also then effectively, I guess, it entrenches that complexity because it's no longer just in one implementation. Now it's in two, and it then effectively doubles the cost of removing it when the time comes for it.
So not all protocol features are alike here. There are some that are much easier to remove than others. And so I think you just have to look at it on a case-by-case basis, to be honest.
Yeah, and to respond to that, I was on some level thinking more about like stuff that's already there that, like, for example, you're avoiding in Zebra by checkpointing past it. So you're just assuming the past behavior. And it's like, well, yeah, we could go and like get Zcashd into a state like that as well. But it's like, is that worth our time versus focusing on things that are currently active right now that we can deprecate and remove, and larger pieces of that? It's like, there's the opportunity cost of, what technical debt pay down benefits do we get the most from based on where we spend our time.
Taylor.
I think it's important to consider also that any code that runs creates some level of security risk and some level of risk in terms of consensus splits and or even accidental interactions with the rest of the code base or changes in dependencies. There's a whole bunch of different reasons, but and I think that we should be evaluating things on a case-by-case basis, but we do need to consider those hidden risks that code that has always worked a certain way suddenly stops working because of, you know, even compiler changes in some cases, and that really does need to be evaluated on a case-by-case. Yeah. So have we. So there is a bug fix in the latest Turkey release that I think will solve a bunch of Zebra problems because, so yes, we wish we never run all of that code because it's been a pain trying to find all these problems.
Yeah, no, I completely agree there. And actually, I'm kind of hopeful that, at least next year, at least on our core team side, we'll be having, we'll be doing work on wallet side. But as far as like the Zcashd stuff goes, I think it's going to be a slightly quieter period after this, and so more opportunities to do that sort of like tearing down of the existing code rather than building up of new code in Zcashd at least.
I think it'd be good to actually start proactively, and I'm not, not saying spending a huge amount of time on it until a new 5 is done, but to actually start maybe having regular meetings to plan for a Sprout deprecation, and to start looking at some of those plans that have been come up with, and move forward with those.
We should maybe consider setting a date when by which people need to have got their coins out of the Sprout pool.
Well, that may not be necessary if we can allow people to spend their coins. My understanding is that
I guess we could do a Halo 2 circuit to allow them to spend Sprout coins.
And as has also been discussed, like they're not gone. If we remove the ability to spend or receive them at all, they're not gone. They're just locked, and you can reintroduce the ability to spend them later. So you can also, like, if no one's doing anything with them, then you can also just take the avenue of, well, remove it and see who complains. And if someone complains, well, then
that's a very good point. It becomes a cost benefit analysis there, doesn't it? It becomes, well, okay, how much effort is it to make it possible to deprecate the Sprout pool but still allow people to spend Sprout nodes versus what's the and so, I
mean, we could even literally say, like, the amount of value in the Sprout pool versus everything else is so small that maybe we do just do the turn it off approach. Here's the turn off date, here's the date there, and then if someone's really going to complain and they would like to help fund or help contribute to getting that in place, then maybe that's an avenue for reintroducing a way to reclaim those funds at a later date. It's not like they're it's the sort of thing, though, that you would want, like, at least to ask the wider community about before doing it. But it is an engineering option.
What is it, like 30,000 coins?
It's 30,000 Zec at this point, and Zec's at what, 10, 11 million at this point, something like that.
266. It's 30,000, then it's $4.6 million worth.
I mean, I obviously have no way of knowing, but I assume there's like a fair amount of like lost keys in there. Like
Oh,
people
very likely.
don't know.
I think that's absolutely fair to assume.
Yeah.
You know.
Although I was talking with someone the other day who's like incredibly well versed in Zcash and the larger ecosystem, and just randomly we were actually talking about deprecating older technologies and not carrying those technologies over to potential proof of stake chain if we were to do that, right? And that triggered that person to go, wait, I have Sprout coins I need to move. Like, you better get on the stick. Like,
Yeah.
So there are definitely some keys out there that are known, but I bet there's quite a few that are lost.
Yeah. Well, maybe we can start. Maybe in the new year we can start having maybe a monthly meeting or something to talk about that.
That'd be nice.
Very good. Cool. All right. Well, we're coming up on time. I've been taking some notes. We'll just keep, we'll do our regular update. And then of course, if there's anything someone wants to jump in on and to update, we can do that, or we can just kind of buffer our time with, continuing kind of a retro discussion. So, oh, Deirdre. Yeah.
Not to kick us off on planning, but since Halo 2 allows recursive proofs, but does not deploy them with Orchard, the use of recursive proving, how are people feeling about when/if that would be prepped for another network upgrade?
Well, we're adding recursion right now, not to go in Orchard, but we're working on it. Yeah.
Huh.
Yeah.
Recursion for the Halo 2.
For Halo 2. Yeah. Just the capability. Yeah.
In the Halo 2 crate, or for the proving of Orchard proofs?
No, the crate.
Okay.
Strad.
Okay.
What is being implemented as part of the ongoing work is the ability to use a variant of the Halo 2 systems. Like it's you can think of what we have in Orchard as the Halo 2 like core proof system, and then the recursive stuff is built around that, and the architecture, the frameworks and things to enable you to use to build the recursive stuff. And so then you can think of taking the Orchard circuit and making it the application circuit in some kind of recursive context. So
it's worth pointing out that if you wanted to make a succinct blockchain that supported Orchard, there's a lot of extra work to do, because a lot of that is currently tracked outside the circuit. And so you would need to write circuit code for those consensus checks. And that's a whole bunch of work.
Yeah. So that's
and you have to decide sort of what directions to take with that. Like you could imagine like a low stakes version of this, you could imagine would be the ability to just do cross transaction proof aggregation per block.
Yeah.
And having miners.
To my proposal for aggregated.
Right. That's Dara's. What is it, like 4868 or something, Dara? Is that the issue number?
I can't remember the number. The number of tickets has increased past my usual memory capacity, which shows you how many tickets we have.
But so this is being added into the Halo 2
crate, the implementation now. So yeah, that is ongoing. So like the Halo 2 crate 0.1 is the thing that will be used by Zcashd 5.0 and Zebra and that, which will be, this is the version of Halo 2 that provides the proving system that Orchard uses for Orchard.
Ticket 4946 shows a transaction.
I was at a couple of digits right, but that's about it.
Yeah. And then the recursive versions, like those would be published in like a Halo 2 0.2, for instance.
Okay.
So we would have the ability to like pin 0.1 for the purposes of continuing to use that for non-recursive Orchard purposes. And then if we were to bring in some variant of recursion, however we chose to, onto Orchard specifically or onto larger Zcash usages, we would pull that in for that purpose. And then again, if further down the track, if we then are in this hypothetical, all recursive case, and we decide to then deprecate, the non-recursive stuff, or we've made a hard switch or whatever, then we would just drop the 0.1 dependency, for instance.
Okay.
Yeah.
So given that there are currently no plans to do recursion in Zcash, what's the motivation for this work going on at the moment?
Well, we have a collaboration with Filecoin and the Ethereum Foundation.
Okay.
Yeah, that's one driver. And it's kind of a, at least as I zoom out a little bit, it's kind of an additional building block on the scalability track, meaning with the recursive capability in Halo, then if we needed to do, for scalability reasons, transaction aggregation or block aggregation, we've at least got the technology developed where we can begin to slot that in.
Yeah. So if you think of like the engineering complexity of NU5 cycle, and the fact that we were developing the Orchard circuit, the Halo 2 proving system, and the Halo 2 crate implementation, and the arithmetization thing, sort of all in all simultaneously, it would be great to not do that again. So doing building the recursive part of the implementation now means that then later, if we want to use it for in Zcash context, we don't have to build that bit.
But my understanding is that scalability has been dropped from the ECC priorities.
Well, let's just
at least for Zcash.
Well, clarify that. It's kind of like scalability and UX, or we consider them cross-cutting concerns. So like they're present like all the time. Like we don't have scalability, like we were driving to get Halo in, right, as a specific like milestone on the scalability 2021 initiative, I believe is what it was called. But it continues to be like a cross-cutting concern. We'll just have the building blocks in place that we could more easily and more rapidly introduce some sort of scalability solution practically if we needed to, because of block congestion, for example.
Yeah, from my perspective, in the design of NU5, we wanted to make sure that we were within stabbing distance of a scalable protocol,
right?
So that should we have a scalability crunch, we would then be able to deploy that in a reasonable time scale to avoid the worst of the congestion.
Right.
Orchard was deemed the bare minimum to enable a scalable protocol,
right?
And we were trying to bite off as little as we could chew. Lol.
Yeah, well, we added transaction non-malleability, transaction ID non-malleability in unified addresses, so that, yeah.
So if we don't have the retooling of the application circuits to enable the leveraging of recursive proofs with Halo 2 in Orchard on the roadmap, this was a major upgrade that bought us what?
Well, no trusted setup for one thing.
Yeah.
Right, but I thought it was also, well, it's not faster, they're about the same size and speed, no trusted setup. We were gonna get recursive proofs, but they didn't fit in this network upgrade. Are we gonna get the recursion, or is it just literally, we might do this at some point?
We are
Is somebody else getting the recursion?
I think it's likely we will get the recursion. Like the way I see it is we could not get recursion without doing this step of work.
Right.
Yeah.
Because the fundamental problem was that the pairing friendly curves that we were using and the curve structure we were using were just not compatible with the kinds of recursion that that were reasonable to do in our Zcash context. With Orchard now being a thing, that is now possible. And so the migration of people, like you've seen how long it's taken to get people to migrate from Sprout to Sapling. people can now start the process of migrating from sapling to orchard, which means that then if we need to roll out, or when we get to the point of rolling out the scalability thing, which won't be able to support the earlier versions, we'll have a much easier time of deprecating and getting rid of them because there'll be fewer people who are actually using it.
Hopefully. I'm mostly thinking of the like, we've been working on this thing for over a year and it's finally released. What do we get for it? Another shielded pool with completely different cryptographic primitives with no trusted setup that we might use for recursive proving someday. We don't know when.
And much better.
I don't know if that's a fair way to characterize it.
I'm trying to think of the wins
No.
other than it is nice.
Well,
and a much better understanding of how to build proof systems.
Yeah. Well, again, I think
Telling someone to use Zcash with the new thing that we've been working on for over a year.
Right.
I'm trying to think of like the sales pitch for Orchard, other than no more trusted setup.
I know different people have different opinions of the value of like no trusted setup. The data points we have are that, that's kind of an issue for folks. So that's a big one. To Dara's point, we're in stabbing distance of a scalable implementation if we needed it due to demand, right? If we hadn't done this, then that's out of reach. That's a 15 month window if we hit some kind of congestion we had to address. Unified addresses is, in my opinion, a pretty significant UX improvement.
But that fell out of, instead of doing sapling on Halo 2, we're doing Orchard. And that you can't do sapling on Halo 2 because of the new curves and all of that stuff. But it's also
Orchard,
like you could have done it with sapling and transparent.
Orchard is sapling on Halo 2.
Yeah.
Yeah,
right, but you can't, you have to do new curves, you have to do the whole thing that grew out of it because,
because fundamentally you need a new root of spend authority on a new curve.
Right.
Yeah, I mean, if I can throw a wrench into the works, it technically is possible to define a half pairing cycle on the scalar field of BLS 12.381. And then use ECFFT to do the FFTs on the so-called not FFT friendly
ECFFT
curve.
being the thing that was only discovered a couple of months
ago,
discovered and we did not know about a year and a half ago.
Yeah, so the timing is impossible, but if for the sake of argument we'd known about ECFFT earlier, then that could have been a thing. But that's in some other timeline.
Okay, so I guess I'm going back to my original question is basically, it sounds like we're not like, my impression was like when we were finishing up with like the planning and the specifics of Orchard, it's like, cool, we deploy Halo 2 now, and imminently the next thing is use it for recursive proofs. And it sounds like that's not the case.
Well, I mean, it could be, but we're not. I mean, it would be really, I don't think, appropriate for us to come on this call and say, "Hey, by the way, here's what we're doing next." Like it or not.
Sure.
So,
but
I mean, if that's like a valuable thing, then absolutely. We could definitely do it. Now, the question is, with block utilization like it is today, is that worth the cycles at this time to add that capability in? And I'm thinking of, again, like transaction aggregation, potentially block aggregation, right? So,
okay.
Yeah, I do seem to recall making that argument previously in a previous role of mine.
I think. I mean, to me, it's a strong argument that we're now within reach of being able to add recursion, and we weren't before.
But it's clear now that ECC's focus in terms of the scalability is on the Filecoin partnership.
Well, that's simply adding recursion to Halo. So that's kind of that would be the next building block for any scalable solution we would add, would be that recursive set of libraries. Again, for using generic terms, Trad can talk about crates and designs and architectures, but
the fact that Filecoin is funding work to build the recursive capability that Zcash would then use if it deploys it, to me is a good thing for the ecosystem.
Yeah.
Not only because then the capability will exist, and that the Zec utility has funded other things that have been beneficial to Zec, but also then there are other people using the stack, and the more people who are invested in the stack, the more people who will hopefully be contributing to improvements to it. So, for example, if Filecoin end up using it in their stack, they're going to want some like really decent GPU implementations and stuff for proving and things, because you've seen what they do with their stacks. So there are good side benefits to that kind of collaboration and having other people invested in the same ecosystem stack. And I see it as a we all win from the improvements that we get to the common code base that we have.
Also, there's some synergy to the VDF work that's being done based on recursive snarks for Zcash switching to proof of stake, because I think most proof of stake protocols, I mean, certainly Ethereum does use VDFs. It's likely that we would probably use a VDF, I think, if we move to proof of stake. I'm not sure about that, but
potentially for leader election, right there for block proposal. Yeah.
Can I interest you in a nice Sogeny-based VDF that would be quantum secure and possibly very inefficient, but
you can interest me, you can nerd cite me, but I do think that recursive snark-based VDFs are going to be very practical.
Yeah. Taylor also had a great comment in chat. So getting rid of trusted setup also lets you respond to making bugs in the circuit, making future circuit changes way more easily than running a new ceremony. Great point, Taylor.
It's definitely a nice win. You just get to upgrade your common dependency, and then you have a new parameter set for the circuit.
Yeah, it becomes a software upgrade problem rather than a
But playing devil's advocate, we could have used Plonk on BLS 12381 for that, but we decided that the ability to support recursion in future was a high priority.
Okay, well, whatever we're adding, I guess we'll have to keep the possibility of moving to recursive proofs in mind for stuff like ZSAs and stuff.
Right.
Yes.
If it's not becoming available sooner, rather than we have it in the back pocket if we need it or something like that.
I mean, we can add things that are not directly scalable, provided that their anticipated use is not going to be the bottleneck.
Yeah. The lens that I see, like, post Orchard upgrades through, one of those sort of questions we can ask is it going to be like compatible with a potential scalable architecture? Are we adding something? So in the same way that the way that we've looked at TZEs in our sort of long process the goal there is to be able to sort of restrict and understand the ways people want to use them, so we can then be able to analyze that for a potential shielded programmability upgrade, like constraining and managing the complexity in a sense. So
in the particular case of CSAs, I don't see any obstacle to scalability from doing CSAs.
Yeah.
Because they're basically such a small change to the circuit that I don't think that would be a problem.
Yeah, the current proposal is quite minimal, and I don't see an issue in it as well. But it's one of those things like, okay, we're not doing this soon, so anything that we do and make changes between now and maybe we deploy it if we need to, we'll have to keep in mind a possible proving scenario to fit it in to designs and additions and stuff like that.
Yes. And in fact, I would argue that it's more likely that what we will sometimes focus on in that time is what can we remove from the protocol and deprecate and get rid of that isn't compatible with a recursive future.
Right.
Definitely.
Okay.
And again, the same thing will apply if we explore other features like pay to verification key or stuff like that.
Exactly. Yeah.
All right, very good. Okay, we're actually a little over, so we'll kind of wrap today unless someone has anything else pressing. Again, no Arborist call in 2 weeks, so meet back up again in 4 weeks. Hope everyone, if we don't talk before, has an incredibly happy holiday season and gets to relax, spend time with family, and enjoy themselves and rest up. So,
Happy New Year.
yeah.
Happy holidays.
Talk to you all later.
Happy Yule.
Happy Yule. Yes. Happy Yule.
All right, everyone, take care.
Bye. Thank you.